Yay! Time for a maths lesson! Woo!
Hello, I've got a lesson for you today on sampling data. Now this is basic sampling, so it appears in the GCSE at both foundation and higher levels. And just before I carry on with the lesson, you'll find a link underneath the video which takes you to the exam questions for this topic. Now it might be worth pausing the video at this point and downloading those files first, because one of the questions, the first question in that link, is one of the questions I'm actually going to be going through today, just with different numbers. So if you want to be able to practice while I'm doing the question, then download that file first and then carry on with the lesson. Sampling data then is all about gathering information on a smaller scale in order to be able to make decisions on a bigger scale. Okay, so you'll all be familiar with samples and sampling in some different contexts. So let's just have a look at a couple of those. So for example, if you were going to paint your room, you hopefully wouldn't just go out, buy a pot of paint and slather it everywhere. If you're at all sensible, you would try and get some sample colors and see which ones work nicely together, see which ones match your room, which ones are going to end up looking good before committing to which color is going to be best. Or if you wanted to go out and buy some things, say some fragrance, maybe you would try a few sprays of different things, aftershaves or perfumes first, to see which ones you like, see which ones you think fit you, before committing to spending your cash on the one that you want to get. Or free food, what a win in life! It might be sometimes that you find free samples of food in shops. And that's to try and get you to work out if you really like it and then try and get you to buy it as well. And then lastly, if you're a gamer, it might be the case that you're used to downloading free demos of games to try them out first. See if you like the graphics, the gameplay, the storyline, and try and get you hooked a little bit on the game and before you can then actually go and buy it. So lots of ways that we use samples in life to help us make decisions on whether we should commit to something or whether we should spend on something, etc. In Maths GCSE, sampling data is nearly always about asking a question of a group of people to try and get an indication what a bigger group of people might be thinking. So, for example, if I had a question for this group of people here, rather than me asking every single person within this circle, what I could do is select a few people, so this light circle here, and just ask them the question instead. And what I'd do with their answers is I'd multiply their answers to the bigger scale, so it gives me an indication of what the bigger group might be thinking without me having to ask every single person. Now, asking every single person would obviously be perfectly accurate because I get all their answers. A sample is just an estimation of what the bigger group might be thinking. Now, a few things that make that estimation a bit more accurate. Normally, a random sample is better. So if I picked people at random, that's normally better than me asking a specific age range or a specific group of people. And similarly, the bigger the sample, the better the results generally, because they've got more data to base my indication and my estimation on. So the bigger the sample, normally the more accurate the estimation that I'm going to be making. Okay, let's have a look at some of the exam questions. You might want to bring your file up now as well. So I've got this question in front of me, which is a typical sampling data question. Now, let me just show you the file that I've attached to this. You'll see that the first question in the file attached is near enough exactly the same. So Hannah is planning a day trip. Hannah is planning a day trip. The only thing that I've changed is the numbers in the question. So this is just so you can have a go at the same time as me, but trying it with different numbers to see if you can get the method to work for you. Okay. Now there's 3 questions I've attached in total. They all have near enough exactly the same format. These are just taken from exams. They've nearly enough got exactly the same format, and they will all use exactly the same method. So if you can get the method right on this first one, you'll be able to get full marks on every single one of these questions. Okay, so let's go through it. I'm going to go through it just as if I was doing it in an exam. So Hannah is planning a day trip for 210 students. She asks a sample of 60 students where they want to go. Each student chooses one place, and the table shows information about her results. And so we've got a table here which is showing her results from the sample that she's collected. Now I'm going to stop there and actually just label this as sample. Now the reason I'm going to do that is so that I know that all this data here relates to the 60 people Hannah's asked rather than the total amount of people. Okay, so that's going to help me clarify things later. Two parts to this question then. First part, work out how many of the 210 students you think will want to go to the theme park. So that's part one. And part two, state any assumption you've made and explain how this might affect your answer. We'll start with part one, obviously. And there's a few things I'm going to want to highlight to help me answer this question. The first thing I'm going to want to highlight is how many people are in the sample that Hannah's asked. Okay, so if we just read the question, Hannah is planning a day trip for 210 students. She asks a sample of 60 students. So I'm just going to highlight that. Okay, so a sample of 60 students. Okay, and that's important because it's going to tell me how much this table is out of. So for example, the theme park is 22 out of 60, theatre is 18 out of 60, sports centre is 3 out of 60, seaside is 17 out of 60. So that data is all out of 60. Okay, we want to know how many of the 210 students, so the total amount of students, we think are going to want to go to the theme park. Okay, so second thing I'm going to highlight here is theme park. Okay, so let's just highlight that, and I'm going to do that just so I know which data I'm collecting here. So theme park data just there. All right, so that's all I need to highlight for now, and I'm ready to start working on the question. So how many of the 210 students you think will go to the theme park? Well, it's nice and clear in the table from the sample, 22 students want to go to the theme park, but that sample is out of 60. So it's 22 out of 60. And I'm just going to write that as a fraction like that. So 22 out of 60 are in the sample want to go to the theme park. What I do with that sample data then is I multiply it by however many people there are in the total. So this question, Hannah is planning a day trip for 210 students. So I'm multiplying by 210 here. And that is it. Okay, so that is my method for finding an answer to this question. Theme park is what we're looking for. We know that 22 out of 60 people wanted to go to the theme park, and we're multiplying that by how many people there are in total. Okay, I'm going to bring up a trusty Casio calculator then to help me answer this question, and just type in this question. So 22 out of 60 and multiply that by 210. Now, if you don't have a fractions button on your calculator, you can just do 22 divide by 60 times by 210. And that's going to give me an answer of 77. So I'm going to type that in there. And that is the answer to that question. So 22 out of 60 times by 210 is 77. That's both marks for that. Part two then, state any assumption you've made and explain how this may affect your answer. Well, this assumption and the effect is nearly always going to be the same for any of these questions. The assumption that we're making is that the sample that Hannah's picked, their results reflect the opinions of the total group. Okay, so these 60 people, that they are in the same proportion as the 210 people in total in terms of their opinions. So that's the assumption that we're making. So the sample data reflects the opinions of the total group. That's part one, the assumption that we've made. And it says, and explain how this would affect your answer. Well, if they don't reflect the total group, then our estimate would be wrong. If the data doesn't reflect the total group of students, our estimate would be wrong. You don't need to be so wordy as that, but it's just nice to be clear for that. So that's absolutely it for this question, all 3 marks, and it's exactly the same method for all the different questions to do with sampling data that I've attached here. So, method then for part 1, find out the sample size and make that a fraction for the data that they're looking for. So theme park was 22 out of the sample size of 60, times that by how many people there are in total. 210 students wanted to go on a trip, and that gives you your answer for your estimate. And the answer for part 2, nearly always the same for these questions. If the sample data reflects the total group's opinions, then our estimate's going to be right. But if it doesn't reflect it, then our answer's not going to be right. It's going to be wrong. And that's pretty much it. I hope that helped. Remember, this method should work for all of the other exam questions on sampling data. That's it for the end of the lesson. I'll bring the question that I've done up side by side with the first practice question so you can do that while being able to see my notes as well. But otherwise, from me, it's goodbye and see you next time.